All right, ready for a deep dive? Today we're going to get into forces and friction.
Ooh,
You
physics.
got it. But don't worry, we're not going to get bogged down with a ton of equations and stuff.
Right.
We've got this really cool resource from Singapore that uses interactive simulations to make it all come to life.
Oh, wow.
It's all about how these concepts are taught to students at different levels and how they sometimes totally misunderstand.
It's really interesting, yeah.
So this resource, it starts by showing how forces and friction are introduced to younger kids using examples they can actually relate to.
Right. So like pushing and pulling,
Exactly.
like magnets.
Magnets, gravity, even just dropping something,
Yeah.
like
Yeah.
primary and lower secondary levels, right?
Exactly. Just building a
It
foundation.
reminds me of when I was a kid trying to push this huge box across the room,
Uh-huh.
and I couldn't get it to move.
Yeah.
I didn't know anything about friction back then, but I definitely experienced it.
You felt it.
I felt it. And you know what's funny? This resource also talks about all the misconceptions students have about forces, even as they get older.
It's interesting because we all have these like intuitive ideas about how the world works, but sometimes our intuition can be wrong.
Oh, yeah?
Like the idea that only active things can exert force.
Yeah.
So you might think, okay, a person pushing a box is exerting force, but some students don't realize that the box is pushing back
Really?
with an equal and opposite force.
It's pushing back.
Yeah.
That's wild.
And another one is the misconception that an object always moves in the direction of the strongest force.
Wait, so if I'm pushing a box to the right and someone else is pushing it to the left but with less force, wouldn't it still move to the right?
Well, it's not always the case. It actually moves in the direction of the resultant force.
The what?
The resultant force. It's like all the forces combined.
Okay.
Like a tug of war where it matters how strong both sides are pulling.
So all those sources are having a hidden conversation, and we only see the outcome.
That's a good way to put it. And this resource uses a file cabinet as an example.
A file cabinet?
It shows how all these different forces interact.
Oh, cool.
In the first scenario, you just see the file cabinet sitting there.
Right, just there.
No net force, totally balanced.
Okay.
Then someone tries to push it,
Right.
but they don't push hard enough to overcome static friction.
Static friction.
The force that keeps a stationary object at rest so the cabinet doesn't move.
So it's like a stalemate between the push and the friction.
Exactly.
Wow.
And here's where the simulation is awesome. You can actually visualize the forces.
Oh, really?
Like you see them as arrows, pushing and pulling. You can see how they balance out.
So we've got our file cabinet,
Yeah.
and there are all these forces at play, but it's not moving.
Right.
What happens next?
So in the next scenario, the person pushing finally uses enough force to overcome that static friction.
Okay, so they're really pushing now.
Yeah, and then the cabinet starts to move.
Right, it's moving.
This is where we transition from static friction to kinetic friction.
Kinetic friction, so that's the friction when something's moving.
Exactly.
Got it. And it's usually less than static friction.
Oh, so that's why it's easier to keep something moving than to get it started.
Exactly.
So even the type of friction changes depending on whether something's moving or not.
You got it. And this is a perfect example of Newton's second law.
Oh, yeah, I remember that force equals mass times acceleration, right?
Exactly. The greater the force, the greater the acceleration.
Okay.
And the simulation helps you actually see it, not just as a formula, but as an actual interaction between forces.
It's like you're part of the experiment.
Yeah.
I love that.
You're not just reading about it.
But, okay, here's what I'm really curious about. The resource talks about this misconception about constant velocity.
Okay.
Like when an object is moving at a steady speed,
Huh? Yeah.
it seems like you'd need to keep applying the same force to keep it moving at that same speed.
Right. A lot of people think that, but the resource says that's not true. Why is that?
Well, once the cabinet's already moving, you only need enough force to overcome the kinetic friction, just the force that's trying to slow it down.
Oh, so you're not actually pushing with the same effort.
Not exactly.
That's a subtle difference.
It is, but it's a really important insight.
So once you get past that initial static friction, it's a whole different ballgame.
Exactly.
And this simulation shows you that visually.
Yeah.
I'm really starting to see why this resource is so engaging. But here's a question. Is pushing a file cabinet really that complicated?
Well, there's actually more to it than you might think.
Okay.
The resource even throws in an extra element, moments.
In moments. Now I'm really intrigued.
So think about it. If you push the file cabinet near the top, it's way more likely to tip over, right?
Yeah, makes sense.
Because you're pushing farther away from the base.
Right.
It creates a turning effect.
Interesting.
Moments are all about that turning effect, the force's ability to cause rotation.
Okay, I'm starting to get it.
The simulation actually shows how the contact point between the cabinet and the floor shifts around
Yeah, shifts.
to keep it from rotating.
Whoa. So pushing a file cabinet isn't just about forces in a straight line.
Right.
It's also about these rotational forces,
It's a whole other layer of complexity.
these moments.
Yeah, but we'll dig into that a bit later.
Super.
For now, let's focus on the basics of forces and friction.
Okay, sounds good. There's a lot to unpack there.
There is.
Wow, this is fascinating stuff. So much to uncover with these interactive simulations. It's amazing.
It is, and remember, we're just looking at pushing a file cabinet.
Yeah.
This resource has tons of them covering so many different physics concepts.
It's awesome. There's so much to explore.
There is.
But okay, you mentioned that the simulation shows how different surfaces affect friction.
Right.
I want to know more about that.
Okay, so imagine trying to push that file cabinet across different surfaces.
Okay, different surfaces like what?
Like a smooth wooden floor,
Okay.
or thick carpet, or like ice. Okay, yeah, that would take a lot less effort.
Totally different amounts of effort.
Yeah, pushing on ice would be so easy compared to a carpet.
Exactly. That's all because of the coefficient of friction.
The what?
The coefficient of friction, it basically measures how much two surfaces resist sliding against each other.
Oh, okay.
So like a higher coefficient of friction means more resistance.
So rough surfaces, like a carpet, have a higher coefficient.
Yeah, and smooth surfaces like ice have a lower one.
Makes sense. That's why it's so much easier to slide on a polished floor than a carpet. Less friction to fight.
Exactly. And that's where this simulation is really cool.
Okay.
You can experiment with different surfaces and see how it affects all the forces.
Wow.
You can actually see how the friction force changes.
It's like having your own physics lab.
It is.
But okay, let's go back to those moments you were talking about.
Right.
It's still kind of a mystery to me.
Okay, so remember how you were saying if you push the file cabinet near the top,
Yeah.
it'll probably tip over? Right, because you're pushing further away from the base.
Exactly, and that creates a turning effect. So moments are all about that turning effect.
Okay,
It's the force's ability to make something rotate.
gotcha.
The simulation actually calculates those moments, and then it shows you how the contact point between the cabinet and the floor shifts
The contact point actually moves.
to stop it from rotating.
Whoa, I never realized there were so many things going on just from pushing a file cabinet.
It's pretty cool, right? It shows you how all these forces work together to keep it stable.
So it's showing you these really complex concepts without even showing you the rotation.
Yeah, and it kind of opens the door to exploring even more advanced ideas like rotational equilibrium.
Okay, rotational equilibrium, that sounds complicated.
It's basically the idea of balancing those rotational forces to keep something stable.
Wow, it's like every time we learn something new, it opens up a whole new layer of complexity.
Totally.
But how are students supposed to understand all of this? It seems like a lot.
Well, that's why this resource is so good. It breaks these complex concepts down into manageable steps,
Oh, okay.
uses examples everyone can relate to,
Makes sense.
and these interactive visuals. So it starts with the basics,
Right.
builds a solid foundation,
Gotcha.
then slowly introduces those more advanced ideas.
So it's not just about remembering formulas.
No, it's about understanding how it all actually works.
I love that. And having fun with physics while you're at it.
Exactly. And speaking of fun, this simulation lets students experiment with different things.
Like what?
Like, they can change the angle of the push, how much force they're using, the type of surface,
Oh, cool.
and they immediately see how those changes affect everything.
So it's like they're getting to play with physics, test out their own ideas.
Exactly.
It's definitely not like those boring textbooks I remember.
No! You know, this whole conversation has made me realize that we take so much for granted.
Like what?
All these things we do every day. Like,
Yeah.
we never stop and think about all the physics going on.
It's true.
Like walking and running, pushing things, pulling things.
We just do it.
Right, but under the surface, there's all this physics happening.
It's like there's this whole hidden language of physics.
Mm-hmm.
And this simulation is helping us understand it.
It's making all those invisible forces visible, which is really amazing when you think about it.
It is.
And by showing us all these hidden complexities, it makes you really curious.
Yeah.
Reminds us that even in the simplest things, there's so much to learn.
There's always something more to discover. We've really uncovered a lot today just by talking about this one example.
It's true. And remember, we've only looked at pushing a file cabinet.
Right.
This Singapore resource has a whole bunch of these simulations.
Yeah, like a whole library.
For all kinds of physics concepts.
It's pretty cool. There's so much to explore.
There really is.
But before we go, I want to leave our listeners with something to think about.
Okay.
So imagine you're back in that simulation, pushing that file cabinet. But this time, instead of a smooth floor, you're pushing it across different surfaces,
Okay, different surfaces, like what kind?
like carpet, ice, even sandpaper.
Okay.
How would those changes affect everything? How would that change the forces?
That's a really interesting question.
What does that tell us about how friction works in our everyday lives?
Well, think about it. How much effort does it take to push something heavy across a carpet
Yeah.
versus like a smooth floor?
Oh, yeah, big difference.
It's a huge difference, and now we know why.
Right, because of that coefficient of friction.
Exactly. Rough surfaces mean more friction.
So pushing on sandpaper would be way harder than pushing on ice.
Exactly. But it's not just about pushing furniture.
Right?
Think about driving.
Oh, yeah.
Your tires need friction to grip the road.
To stay on the road.
Right. On a dry road, there's more friction, so your car can speed up and slow down easier. But on a wet road or an icy road, there's less friction.
Which is why it's so dangerous.
Exactly. It's way harder to control your car.
It's like friction is helping us and fighting us at the same time.
That's a good way to put it.
It helps us hold things, stay stable, move around.
Right?
But then it also makes us work harder to overcome it.
Yeah, and we use friction to our advantage all the time.
Oh.
We use lubricants to reduce friction in machines.
So they work better.
Yeah. And we design tires with those treads to increase friction on the road.
And we even use it to make heat.
Yeah. Like rubbing your hands together when it's cold.
Exactly. It's amazing how friction is everywhere.
It really is. It's all thanks to this resource from Singapore that we got to explore these ideas in such a cool way.
It's true. I mean, who knew physics could be so fun?
It really can be.
It's a good reminder that even the simplest things can teach us so much about the world.
Yeah, there's always something more to discover.
Well said. So to everyone listening, I encourage you to check out these interactive simulations.
Yeah, they're really cool.
Explore the world of physics and never stop asking questions.
Keep that curiosity going.
You never know what you might find. Until next time, keep diving deep.